So we have previously discussed motion in plane, like if this is our axis system. If we are taking the x-axis and we are taking y-axis, and any movement from a point to B, from a point to the point B, we can just resolve this two into these two parts, into this part and that part, and this will be our x, the component of the motion in the x direction. This will be the component of the motion in the y direction. So even if we take a velocity in this direction, it can be resolved into this direction and that direction. If we take acceleration in this direction, it can be also resolved in this direction and that direction. So anything, any vector can be resolved into two parts, where this will represent the x direction component in the x direction, and this will just take this will represent the component in the y direction. Hence hence now we'll be dealing with a interesting topic which is called the projectile motion, and which is a very interesting uh, topic, and very fun topic, because this is one hell of a example when it comes to a motion in plane. So what is a projectile motion? Projectile motion is any a motion where this is our ground, or surface of the earth, and uh, throughout in the direction from this point to on this direction on the ground, we are taking the x direction. Hence perpendicular direction of this, that means perpendicular to the ground, the height from the ground will give us the y direction. And hence if we throw anything from the ground on this direction, eventually this will move in a path like this. It will go up, and eventually it will come down and reach the ground again. Hence many examples can be given, like we can throw a ball, it will go up, then it will come to the ground. In sports, the always, if something is going up, it never goes like this, it never goes up and up and up. It will go up, and it will have some horizontal component, some vertical component, and eventually it will come down. So this type of motion is called the projectile motion. But here we are going to make two assumptions. One, the movement is taking place near to the earth surface, near to the earth surface, so that the rules of gravity can be applied here, and the constant of the gravitational acceleration can be taken as g. And number two, again, like any other assumption, air resistance would be neglected. Air resistance would be neglected. Air resistance would be neglected. Here, we will be dealing with uh, the anything that can be happen by the air, by the presence of the air, is neglected. So anything uh, like when we are playing badminton, if a shuttle is shot, and if air is just making it move in the other direction, those are just neglected here. So it is assumed that if something goes up, and only gravity will work, and eventually it will come down. Gravity will work, and the movement in the x direction would also work. Here a question can be asked, like a intuitive explanation can be asked, like why it goes up and this direction, and eventually it come down, it reaches a height and eventually it come down. It is because, see, the velocity in the x direction is remaining the same. It is just moving, it at each point of time it is moving with the same velocity in this x direction. But but the thing is, when it is going up, it is decelerating by the amount g, That means if it is going up by 20 meter per second, then the next second it will go up by only 10 meter per second, because gravity acceleration is 10 meter per second square. It is approximately this value. Hence, at each second, if it is going up by 20 meter per second, next second it will go up by only 10 meter per second, and eventually it will stop, because the next second it will go and have only 0 meter per second. It will stop going up, then eventually this will come down, like it will become -10. That means it will be coming down by only by 10 meter. Then in the next second it will coming down by 20 meter, and hence eventually it will reach the ground. And this is why if we just look at the path, each second the y component is going down. Y component is going down. You can see at each, eventually it will come 0, then it will start coming down, it will start coming down, it will start coming down, it will start coming down. And this is how at each second the component, the movement on the y direction is getting less and less and less until it will reach a maximum height, then it will start falling. So this is how the projectile motion works. And the movement in the x direction, it is not stopping, it is going, and there is no change in velocity in the x direction. So like any other thing, let's say, let's take a projectile motion, and let's take it as a origin point 0. This is 0 comma 0, and and a the particle is thrown in this direction with a angle theta with the x direction, and eventually it will go up, 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 then it will come down, and it will reach a point r on the x-axis. So this distance or on the x direction, it is called the range of the projectile. Range of the projectile. This is just the range of the projectile, because how much distance or how much displacement it has covered throughout the x direction. So OR will be our range of the projectile. And the maximum height here, it will be around this point. An interesting thing happens on the maximum height here. The velocity in the y direction becomes 0. Here it was positive because it was going up and up and up, because we are measuring this direction as the positive y direction. Here the velocity in y direction will become 0, then eventually it will fall. That means it is going in the negative direction. Hence here the velocity of y will be negative, but in the here the velocity component in the y direction was positive because it was going up. But x is always positive because x is going here, here, and here. So x is always positive. Velocity along the x-axis is always positive, and it is not changing, it is constant. Hence, we can take this as our height max. That means h max, that is the maximum height. So let's start. Let's say the initial velocity was on this direction, which was our u. Now this can be resolved into two components. On the y component, this will be ux, and there will be a uh, the x component, this is ux, and there will be a y component, which will be our uy. And we can take the magnitude of ux as u cos theta, and uy will be u sin theta. Hence, it is because, see, this is our ux, this is our uy, and this was our the vector which got resolved into uy and ux. It was u. If this is theta, and we can just we can just parallelly take this ui here, and this is u, this is 90 degree. That means perpendicular by base u by ux is equal to, not the perpendicular, this is the hypotenuse, ux 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 by u is equal to cos theta, hence ux will be equal to u cos theta, and this is just 90 minus theta, and this can be written as, or this is our uy, this is equal to ui by u is equal to sin theta, hence ui is equal to u sin theta. So these two components are resolved, and hence we will just analyze we will just analyze the horizontal motion and the vertical motion separately on the projectile. In the horizontal motion, the initial velocity is u cos theta, ux is u cos theta, and here no acceleration is present because it will move on each second only by u cos theta amount. Hence, acceleration in the x direction is equal to 0 because there is no accelerating component or acceleration component in the x direction. Hence, if we take any point of time, vx at any point of time t, it will be just ux plus at. Here axt, here ax equal to 0. Hence, vx will be always equal to ux. Number one. Number two, the displacement in the x direction, x will be equal to ut plus half at square uxt, and it will be just x will be equal to u cos theta into t, which can be written as ut cos theta, and which makes sense because if it is not, changing the speed, if the car is going 20 kilometer per hour every hour, then after 4 hours it will be just 20 into 4, it will be 80, and if it goes by 5 hours it will be 100 because the velocity is not changing. Hence, by only multiplying the time with the x direction velocity, we will be getting the horizontal displacement the uh, uh, object is capturing. Now, the last equation will, which is not required, but let me show you, v square plus ux square plus twice ax x. This component is 0 because ax is equal to 0. Hence, vx square equal to ux square, which also makes sense because the velocity at any point of time is same as the initial velocity. So our horizontal component is done. But in the vertical component, in the vertical motion, ux initial uy is given as u sin theta, and here the acceleration is minus z because we are taking this as the positive y direction. Hence, because the gravity is pulling us down in this direction, hence it will be taken as minus z, and hence at any point of time, vy will be uy minus zt, which will give us vy is nothing but u sin theta minus gt. Then what we can write here, the y distance that is being covered will be just uy t minus half z t square, where we can write u sin theta t minus half g t square. So, and again v square y will be equal to u y square minus 2gy. So this is just another equation, and these three equations will hold true for the motion in the y direction or the vertical direction. Hence, we have covered the equations for the horizontal motion and the vertical motion. Now let's talk about two important components, which are the time of the flight. The time of the flight. How we'll measure the time of the flight. That means we are a projectile motion. Initial velocity is u, and how much time this particle will stay in the without the contact of the ground. That means how much time it will stay in the air. So that will be called as the time of the flight. Time of the flight. So let's call it time of the flight. Let's call it time of the flight TF. So to measure this, we have our range OR. We have our range OR, and if we know our if we know our u and theta and OR, then time of the flight can be given as OR, the distance in the x direction, divided by u cos theta, because this is the velocity in the x direction. So this equation also can be used, but if we don't know, the range, what we have to do, we have to use this equation. Y is equal to uy t minus half z t square. See here, we only have to know the u and theta, and we will get, because z is known to us, we will get to know about the time of the flight, the t component. Here, interesting thing. See, when y is equal to 0 at two particular points, one when it was starting and one where it was landing. See, here the displacement on y is equal to 0. Why 0? Why 0? Because this was the ground level. It was starting at the ground and it is again coming back to the ground. Hence, the displacement on y will be equal to 0, or the coordinate of the y is equal to 0 here. Here the coordinate was 0 and 0. Here the coordinate is r0. That means the movement on the y direction is coming back to 0 because it came back to the ground. Hence, if we make it like this, the coordinate of y is equal to 0, uy, which is equal to u sine theta, u sine theta, minus half into time of the flight. Now it will be half z time of the flight square. So what we can write here, is 0 equal to u time of the flight sine theta minus half z time of the flight square. So if we take tf common, it will stay like this: u sine theta minus half z tf. Now this will mean either this have to be 0 and this have to be 0. If this is 0, if time of the flight is 0, that means y is equal to 0 when the movement was not starting, which is absolutely true. We are talking about this point. If time of the flight is 0, we are talking about the initial point. So this is not equal to 0. We are considering this point only, point r only. Hence this is positive. Then this has to be 0. Then positive number into a 0 will be equal to 0. So this has to be 0 when we at the point r. At point r, that means when the flight is stopping, half z tf is equal to 0. This will give us half z tf is equal to u sine theta, and hence the time of the flight can be measured by 2u sine theta and 2u sine theta divided by z divided by z. We have just algebraically manipulated it. We transferred the 2 here and g here, and we have found the time of the flight is to be 2u sine theta by z. Now let's talk about the range. The range. The range. The range means the distance the projectile has covered from here to here. So this is our range OR. We have found time of the flight to be 2u sine theta divided by z. This is our, and if we multiply it by the x component's velocity, then we will be getting the range. So the range would be u cos theta, that is the velocity in the x direction, into the time of the flight. That would become u cos theta into 2u sine theta by z, which will just give us 2 u square cos theta and sine theta divided by z. This will be our range. If we know theta, if we know u, and if we know g, that means we will be able to calculate the range, how much distance it will cover, now let's let's talk about maximum, right? A maximum height that is reached, maximum height that is reached maximum height that is reached. So something is happening. Wait a second. So let us uh, now calculate the maximum height, reached. So the maximum height can be calculated by a very small trick. See, here, here the maximum height will be reached, then it will come down. So let's take it as height max. And if we consider this point here, one crucial thing is happening. What is happening here? Here, the object is coming to a rest in the y direction. Hence, Vy is getting equal to 0. Here, Vy is coming to 0. Why coming to 0? Because it was going up and up, because the displacement was happening with each second of time. But here, it is coming to a rest. Hence, the y component of the velocity is coming to a 0. Then it is turning into negative. It is just dropping. It is going down in the y direction. Here it was going up. Hence, the velocity is equal to 0. So the velocity in the y direction is equal to 0. That means that will mean that Vy is equal to Uy minus Zt. If it is equal to 0, and we know this was equal to u sine theta minus Zt, which will give us an interesting thing. Zt will be equal to u sine theta, and time when it reaches the maximum height is equal to nothing but u sine theta by z, because at maximum height velocity or in y direction is equal to 0. Hence, by putting 0 in this equation, we are calculating the time when it is reaching the maximum height. Hence, the maximum height can be calculated by this. The y, that means the movement in the y direction, the displacement in the y direction at time t will give us the maximum height. Hence, y at time t it will just give us uyt minus half zt squared, which is just uy means u sine theta, and t here means u sine theta by z here minus half z is given. Now t, we know t is nothing but u sine theta by z whole square, which is just give us z u sine theta whole square minus half z u sine theta whole square by z square. Why z square? Why z square? Because we are just removing the bracket here, and we are just removing as two components u sine theta whole square divided by z square. This z and one z here will get cancelled out, and we can write this expression as u sine theta by z, this is whole square, minus half of the same expression u sine theta whole square by z, which will just give us, we are just removing one, we are just removing a half component, half expression from a whole expression. It will just give us another half of it. So this will be u sine theta whole square divided by z, and which can be simplified by writing u square sine square theta divided by 2z. So this will be our maximum height that can be reached. So in a projectile motion, again, the summary of the class is the projectile motion. A object is thrown in this direction with a velocity u. We first decompose this velocity component into two components. One is the u, if this angle is theta, then this is u cos theta, then this is u sine theta. And we have separated the x movement and the movement in the x direction and the movement in the y direction. And from those we have come to a realization that acceleration in the y direction is equal to minus z, because gravity is pulling in this direction, in the downward direction. Acceleration in the x direction is equal to 0, because no force is being applied here, it is just going uniformly in the x direction. Hence, we came to a realization that the time of the flight, time of the flight, we have calculated by, we have gotten TF is nothing but 2u 2u cos theta sin theta, sorry, not, I am writing wrong equation. TF we have found to be 2u sin theta divided by z, and the range we have calculated to be 2u square sin theta cos theta divided by z, and the maximum height the projectile will reach is given as u square sin square theta divided by 2z. And if we see this time of the flight and time it required to reach the maximum height, time it reached the maximum height, at this point the time was t equal to 2u sin theta by z, but at maximum height the time was t was equal to u sin theta by z. We can see that from this point to this point, half of the time is covered, because this is just a half of this term, half of this term, this is the range, this is maximum height. Half time is being spent here, and half time it is being spent by just by the particle by coming down, and hence we can make this a realization here. And this is about it. This is about the whole projectile motion thing. Just go through the video. I think you can just repeat this video in 1 hour. So this is it for today, and I'll send you some problems uh, after I finish uploading this. So bye bye.